Hi class and welcome to physical geology, and I had a request to make a video on exercises for chapter 8 on geologic time. And the first one here is pretty straightforward. You're using the cross-cutting relationships to determine the different ages of these dikes, these intrusions. And obviously this pink one seems to be cutting across some of the older ones, right? So obviously it's cutting across. So anyways, you're using the principle of cross-cutting relations to determine which unit is younger and which is older, right? So just kind of look at your notes. Don't worry about these vertical lines here. Those are, in fact, you could date them if you wanted to. Those are drill holes that road engineers, put in and put dynamite or blasting caps in there to blow up the rock so that they could make this road cut, right? So anyhow, that'd probably be the youngest thing on here if you wanted to add these drilling by people here. But anyways, you can figure that one out pretty. Well, I guess you're only doing the three, so just do the three dikes there. And then for activity 8.2, this is really important because on the exam I have something very similar where you look at the concurrent age range. In other words, you want to find out when each of these species, these organisms, these fossils lived at the same time, even though they have different age ranges. So the ranges are these yellow lines, yellow bars. You can see each one has a different, but you want to figure out when they all coexisted in time, right? So here we have several species of inoceramid clams. Yeah, so they were common in the Cretaceous. In fact, there's a lot of these in the Central Valley, some of the great valley sequence deposits in California. But we have all these clams, and there's different species of them. They had short durations, which make good index fossils, right? So remember, an index fossil has a short duration. It's easy to identify, and it's widespread. Although these aren't as widespread because they only occur in the kind of intertidal zone near shoreline. They're not all over the place. So they probably would be good index fossils for large regions, but certainly for um, this region, they're pretty good because they have the short duration. All right, so looking at this bracketing method, right? So you're figuring out when they all coexist in time. What possible age range for these five organisms were found in the rock? So I guess we're looking at all five of these, right? Yeah. So you could see that. So if we look at all five, they're going to have a very narrow, because really we can't go any older than this fossil here, um, Subhercenius. Subhercenius starts here at around 92.7, right? And then we can't go any younger than Labiatus here or Hituru here, because they both end at 92.6. So anyways, it has a very short duration, so it's between 92.6 and 92.7, very short duration. So that would be the age range used in all five fossils. If How would this change if somebody were not present? So if this guy were not present, then the age range would go from the base of Labiatus here at 93 point, or 92.9, I guess, 92.9 to 92.6. So it'd just be the age range of this one because that's the only time this guy coexisted. And then we're skipping this guy, but we're including these two. Yeah, so it'd be between 92.6 to 92.9. So anyways, that's how you want to figure that one out. And isotopic ages, I think this is pretty straightforward. I mean, this is a little bit different than how I do it in my lectures because we don't use a graph like this. We use something a little bit different, but there's different ways of doing it. Make sure you understand how I do it on my video lectures, right? So, but this is a different method here. Now here, I had some questions about this one. So here we're looking at these paleomagnetic ages, right? And remember, the normal magnetism would be the black, and the reverse is the white, periods of reverse polarity. And here we want to figure out about what's the question here? Using figure 8.53 for reference, determine the age of a rock with normal magnetism. 5.3 for reference, determine the age of a rock with normal magnetism, right? Between 1.5 and so the only rock with normal magnetism is the black right here. So it's going to be between, so if I can zoom in a little bit here, looks like 1.78 to 2 million years old. So that rock would be 1.78 to 2 million years old, right? So based on that, because that's the only one that has a normal magnetism there, right? Normal polarity. Now, how about a rock? If we look over here, how about a rock that has that is limited to 2.6 to 3.2 million years and has reverse, so 2.6, so right around here to 3.2, which is right in here. So the only one would fit is this, and it has reverse, right? So this, the only white one here, because that's 2.59 right here. So, and it's older than 2.6. So it can't be anything in here. So it's actually, you can define this one pretty closely to, let's zoom in a little bit. Yeah, so the only one that's reverse, that's going up to about 3.2. So 3.2, right, would be this rock right here. From 3, looks like 3.05 to 3.12, right? So that's the rock right there. So that's how you figure that out. I hope that helps. We'll stop for now.